Welcome to Out of the Lab, a podcast interviewing entrepreneurs who've taken research out of the lab and built it into a company that's serving the world. These entrepreneurs are heroes, and the planet needs more of them. So tune in, learn from their successes and failures, and get inspired. Visit bountiful.work to join our community and realize your power to save the world. Hello and welcome to Out of the Lab. I'm your host, Max Finder. Today's guest is Mehrdad Mahoutian. He's a PhD, an award-winning scholar, entrepreneur, and co-founder of CarbiCrete. He invented CarbiCrete's technology, and he is now their CTO. It's an exciting carbon capture and concrete production technology that gets rid of cement, which is one of the biggest emitters, and it's actually a carbon negative process the way that they do it because they also inject CO2 into the concrete. You can hear more about his technology, but also really how he invented this thing as part of his PhD research and how it went, the entire trajectory of inventing it, working with his advisor to figure out if it's novel, working with the technology transfer office to patent it. They introduced him to his co-founder who is a successful entrepreneur, and how he leveraged non-dilutive funding. Mehrdad is extremely impressive. CarbiCrete was just one of the finalists in the $20 million Carbon X Prize. He's published more than 50 peer-reviewed journal papers and conference papers. He has 7 granted and pending patents to his name. He's been cited in 600 papers and reports. The audio is a little rough in this one because he's calling from his R&D lab and it's concrete, so things are a little bit loud, but the content is definitely well worth it, especially for the story of how he got lucky in his PhD research and how that led to the breakthrough that became CarbiCrete. So tune in, enjoy, visit bountiful.work for more, and listen to the episode. Thanks. Mehrdad, thanks for joining us.
Hi, Max. Good to be here with you.
So to get started, I would love to hear you describe the CarbiCrete technology at a high level, but our listeners are a lot of researchers and grad students in hard sciences, so they'll be able to understand it reasonably well, but maybe you could tell us a bit about the CarbiCrete technology.
Sure. Just a bit of background before I talk about CarbiCrete technology, basically. As you may know, concrete made with cement and aggregate. Cement and aggregates are the main ingredients of concrete, basically. So what's the problem? The problem is with cement, not the concrete. Cement accounts about 8% of total CO2 emissions around the world. So imagine for production of 1 ton of cement, 1 ton of CO2, almost 1 ton of CO2 gets emitted into the atmosphere. So you can imagine how dirty and polluted this industry is. And this cement is used to produce concrete. So what we do here at CarbiCrete, we are developing cement-free concrete. So we no longer use cement to produce concrete. Instead, we are using byproducts material. And in our process of making cement-free concrete, also we are activating and curing our concrete with carbon dioxide. So as a result, our concrete also absorb and sequestrate some CO2. And imagine, since concrete consumption in the world is significant, basically. So I guess based on the last statistic and last number, each person in the world consumes about 1 ton of concrete worldwide. So you can imagine how many tons of concrete are used and produced basically every year. And for that reason, if you can reduce the concrete consumption based on the traditional concrete consumption and use new technologies like CarbiCrete technology, we are able to reduce the carbon footprint. We can reduce the CO2 emissions associated with the cement and concrete production.
And this,
if I want to give if I want to, sorry for interruption, Max, if I want to give you some more details on our technology. So as I mentioned, so we are not using cement, which is cement, you know, we can say that that's a troublemaker material. So we are not using cement, and we are using byproducts of other industries. In our case, in our technology, we are using steel slag, which is byproduct of steel manufacturing plants. So you imagine in a steel factory, so the main goal is to produce steel. So steel is the main products over there, but as a result of the production, they are producing and generating some byproducts, which they call it the steel slag. So in our process and in our technology, we use these steel slag. We do some process on the steel slag, and we use it as the main binder for production of concrete.
Excellent. And before we get into the origin of all of this, I mean, there are a few other major initiatives to try to improve concrete and cement. I mean, things like CarbiCrete, which I know is also in Canada where you're based. Could you talk about some of the differences with some of those other leaders that, for instance, just won the X Prize, and how CarbiCrete is different, or maybe you're the same?
Yeah, so as I mentioned, since concrete is a huge issue regarding to the pollution and CO2 impact, so there has, I mean, in the past 20, 30 years, basically, lots of researchers, lots of studies, lots of universities try to solve the issue, or try to at least reduce the CO2 footprints of concrete. So they started, let's say, with making a better cement, less polluted cement, or let's say cleaner cement, basically. So they try to use, let's say, a better fuel, cleaner fuel, using, let's say, some sort of clean energies in order to produce cement. This is one of the ways that they try to, let's say, produce concrete with a lower CO2 footprint. Then another categories and another avenues to reduce the CO2 footprint of concrete was to reduce the cement consumption in concrete. For that reason, another categories basically started when the concrete manufacturers, they tried to use cementitious material, which are not cement, but has some cementitious properties. So they call it supplementary cementitious material, like silica fume, like metakaolin, like fly ash. So let's say I just give you an example. Let's say instead of using 100 kilogram of cement, so you are now able to use 75 kilogram of cement and use 25 kilogram of, let's say, fly ash. So you are able to use less cement, and less cement means less CO2 footprint. So these efforts have been done again in the past 20, 30 years, basically, to reduce this carbon footprint. And recently, so you talk about the Carbon X Prize and another company in Canada, basically. So there are more interest in using CO2 in concrete. So I would say that all of those companies and all of those technologies still are using cement. They are still using Portland cement plus CO2. And that's the main difference from, let's say, CarbiCrete technology, and you talk about the CarbonCure, basically. So in that technology, in CarbonCure technology, for instance, they are using cement, Portland cement, and in their process, they are also using CO2, which is same as us. But the main difference, which is a very huge difference here, is that we are not using cement. We are using no cement at all, cement-free concrete. This is what CarbiCrete does, basically. And that's a huge difference between these two technologies. And as a result, basically, so imagine that we are not using cement. We are capturing lots of CO2 in concrete. And as a result, our concrete, the final product, is a carbon negative product, basically, which is great. So life cycle analysis has been done. And imagine that when you are doing life cycle analysis, you are dealing from the start to the end, basically, from getting the material, raw materials, processing the raw materials, production of concrete, and at the end of the life cycle, basically. So you consider all of these parameters and all of those factors, and it has been done. And analysis showed that our concrete products are carbon negative, which is a very significant benefits of our product, basically.
And you're counting on steel slag as the input to like steel production will not change anytime soon, and so you'll have that input and continue to add value to the environment by removing that as a byproduct from the steel process. Yeah.
Exactly. So since we are using the byproduct of steel manufacturing, again, and that's construction is happening everywhere around the world, and construction needs steel. Construction, car manufacturing, and all of those other industries. So the demand for steel is there and is going to grow. So there are some estimation that it's going to grow almost every day or every 5 days. So definitely steel production is not going to stop. And as a result, we will get access to steel slag, which is a byproduct of a steel manufacturer. And again, if I just want to wrap up basically the benefits or environmental benefits of our process and our technology, CarbiCrete technology, is that first, we are not using cement, which is a very energy intensive and very intensive CO2 footprint material. So we are not using cement at all. That's one main environmental benefit of our technology. The second is that we are permanently capture and sequestrate CO2 in our concrete. So that's also a great environmental benefits of our process. So we capture CO2 inside our concrete, basically. So we convert the gas into some solid and it stays in concrete basically forever. That's the second benefits of our process. And the third benefits of our technology is that we are using byproducts of other industries. So imagine instead of putting those byproducts into the landfills and make more landfill every year and every year and every year, we use those landfills, we use those byproducts, we reduce the size of the landfills, we eliminate those landfills, and basically for that reason we also contributing to the environment basically. And honestly, I'm talking about CO2 a lot, but just don't forget that when cement is produced, definitely it emits lots of CO2. As I mentioned, 1 ton CO2 per 1 ton of cement. But in addition to this CO2 emissions, you have to consider the amount of raw materials and natural resources that are used to produce cement. So for producing cement, you need limestone, you have to dig limestone, you have to dig clay, you have to use the clay. And all these materials are natural resources for us, basically. So when you are producing cement, you have to use all of those materials. You are going to emit CO2, which is not good, basically. So by avoiding using cement, basically you are avoiding emitting CO2, and also you are avoiding using natural resources.
And so was this avoidance of natural resources, the idea of using CO2 and even using the steel slag as one of the inputs instead of cement, I mean, was that the goal when you invented it? And maybe this is a nice segue into talking about how you came up with the technology and the process of inventing this. Let's talk.
Yeah, sure. Yeah, sure, Max. Yeah, I mean, I started my PhD program in 2011 at McGill University in Canada. At the time, I was looking for any material, specifically byproduct material or any waste material that captures CO2, and at the same time, it gains strength. Because honestly, when I started, already there were some known material that could be used for capturing CO2, like olivine, let's say. So there are some minerals called olivine, and they are reacting with CO2, and they can be used for capturing CO2. But since my background is civil engineering and structural engineering, my goal was to find a material that captures CO2 and at the same time can be used in construction materials, basically. So just capturing was not enough for me. I was looking for some strength development and some mechanical performances, basically.
So was this part of your PhD, or was it just a question and a prompt that you started investigating on your own?
No, that was the basic. That was my main goal, the basic goal of the project, basically. It was the main task for me, basically, to find out what material is good, and then investigate it, and then find out the mechanism, find out how it happens, and find out how the reaction happens, and all of those things, what phase, how the chemistry affects the result, how the strength is developed, basically. So that was my research, basically, to find out to answer to all of those questions. How the reaction happens, how the strength is developed, what phases are consumed in the slag, what phases are, let's say, generated as a result of the reaction. So these are all what I had to answer during my PhD program.
But the combination of inputs that you have in this process, I mean, this was a thesis that you had, or you had undertaken some kind of search to try to find out the ideal inputs for this, if that makes sense.
I searched basically. I mean, yeah, well, I searched basically. I tried different materials. I tried different byproduct materials. Specifically, I tried fly ash, let's say. I tried iron slag. I tried wood ash. I tried silica fume, and definitely I tried steel slag to see basically which one is going to be a good candidate for the reaction and for being used as a construction material, basically. So I tried all of those materials and figured out that, okay, steel slag seems working, is a good one. And based on that, I spent more time to evaluate the performances, the characteristics of a steel slag, the characteristics of the carbonated steel slag, and all of those things, basically.
And so once you settled on steel slag, I mean, or I guess after that, I mean, when did it start to feel like a company? I mean, when did you start to do these techno-economic analyses that would help you figure out, you know, that it's an excellent input, that all of the different parameters that made this feel like something that could be its own company?
Yeah, well, I mean, maybe it was my second year, perhaps. So again, I tried different material on steel slag, and then I did not get good results from steel slag. And honestly, it made me a bit nervous because, you know, you are almost in the middle of your program and then basically no good result at all, basically. And imagine all of those issues and all of those bad results. And then suddenly one of our equipments broke, basically, at McGill University. I mean, imagine we had enough problem, now another problem popped up. And it made me very upset and made me even more nervous, basically. So I had to find out another third-party lab, basically, to do the process for us, basically, because no longer I could use that equipment at McGill. So I did some search and research, and then I found out that there is a lab, is a private lab in Ontario, in Canada, that they can do that process for us. So it took 2-3 weeks, basically, for the communication, contract, and all of those things. And imagine, at that time, I was very nervous. How come it broke at this time? Why I'm not lucky why it broke now, basically, and all of those complaints and all of those stuff.
This is rock bottom for a researcher.
Yeah, yeah, true. That's true. But honestly, when you are in the middle of research, you want everything to work as much as possible, basically, and all of those drawbacks, all of those hiccup, basically, you know, you are not looking forward to see those hiccups when you are doing the research. And honestly, all of those hiccups, that is very typical. I agree with you. It's very typical, and it happens, but it delays the project. It delays your program. It delays your project. And usually, as a researcher, honestly, you don't like those type of problems and hiccups. So I sent the material to that third-party lab, like a private lab in Ontario. And after, I don't know, 2-3 weeks, they sent back the material. The same steel slag that I was using, but they processed it at that third-party lab. And then suddenly I started to get good results. And the same material that I use, the steel slag, I could not get good result, all low strength, low CO2 activity, low reaction rate, and all of those things. Suddenly, same material, same everything, same process that basically I did at the university. Then suddenly I started to receive and obtain good results, basically. And it was very surprising. I was happy for sure, because finally some good results popped up and some good results were generated. I mean, in the first few days, basically, or weeks, I was a bit surprised, and I was not sure how come, you know, I mean, everything is the same material, same slag, same everything. Then how come now something is working now? And then just noticed that because we use a different, let's say, grinding equipment, different equipment here at McGill versus the third-party private lab, they're using different equipments. So those guys, they were able to grind the slag better, basically, compared to ours. And they were able to make it finer, let's say. And for that reason, finer slag means higher reaction rate, higher carbon activity, and all of those things. At the time, I guess it was 2012, I guess, I was not aware of the fact that, yes, size of the slag, size of the fineness has an impact on the activity and influences the size of the slag, influences and affects the reaction rate, affects the strength development, and all of those things. And it was a very good accident that our machine and our equipment broke. Because, you know, I noticed that, oh yeah, so size is important here. I'm talking about the size of the slag. And for that reason, that was a very good, again, that's a very good coincidence, very good accident. So, okay, then everything has started to work from that point, basically. So I started with, let's say, making small 2 by 2 by 2 centimeter samples. And then since we got good results, then I started making a bigger sample, 10 centimeters by 7 centimeters, again, good results. And then we moved on and make a bigger sample. So eventually after, it was my third year, I believe, 2013. Try to answer your question from what point and from what time, at what time, basically, we noticed that, yes, there is some hope and some chance that we can start a company. So I guess it was in 2013 that, you know, good results. So I had made some concrete samples, good compressive strengths, good performances, and the samples basically captured some CO2, no cement at all, cement-free samples. And it was in 2013, I guess, I discussed with my former supervisor, Professor Yishin Shao. And then we said that, you know, it's a very great story. You know, we are able to make a concrete without cement, with a good performance, with good mechanical properties, with good durability properties. And at the same time, this concrete absorbs CO2. And we said, okay, you know, it has a chance of commercialization. It has a chance to be brought to the industry. I mean, definitely at the time, I didn't have that much of knowledge about the, let's say, the cost, the economic of this one, the market, how much steel slag available around the world, how much it's going to cost, capex, opex, and all of those things. So definitely at the time, I was focusing on the technology and the science behind it, basically. But that was a triggering time at the time, 2013 perhaps. You know, we saw the hope, and we saw the potential that this technology can be presented to the industry. And at that time, we said, okay, that's a new stuff, that's a new technology. Let's protect the idea. And for that reason, basically, we notified McGill University to say that, okay, yeah, you know, we submitted the ROI report of innovation. We came up with this technology, we came up with this innovation, and we believe interesting technology. And after several meetings with the McGill officials, basically we presented to them, we tried to show them that this is an interesting technology, it's working, it's feasible. McGill agreed to support the patent application and basically pay the fees and all of the application fees and all of the legal fees associated with the patent application. So we submitted the patent application, we protected the patent application, I guess, starting, it was in 2014, I believe. And so the patent application was submitted, so we were sure that the idea is protected. And I guess it was in 2015, early 2015, February 2015, that the Office of Sponsored Research at McGill University. So that office introduced me and my supervisor, my former supervisor, with a business person, basically, a successful business person. And it was in 2015 that for the first time I met with my business partner, Chris Stern. And I presented the idea, I presented the technology, and then he liked the technology. Again, it seems very, at the time, it seems very interesting because, you know, I mean, you are making cement-free concrete with the same and better performance than normal concrete, average concrete, and at the same time, we capture CO2. So it's all good stuff, no brainer. That is a you know, this technology is a very interesting and promising technology. And it was in 2015, and then we said, okay, you know, we have to start a company, we have to start a startup to work on it, and then it takes a few months basically to figure out the best approach to start a company and all of those things, to you know, to work on the mechanics of it, basically how to start a company, and then how to do it, paperwork and all of those things. And it was in July 2016, Chris and I, as co-founder of CarbiCrete, basically started CarbiCrete.
I just want to say I love the story about how it was an accident that they were that the other lab, that the McGill equipment broke, and you had to send the material to another lab, and they ground it differently, and that made all of your results better.
Yeah,
I mean,
it was a, yeah, as I mentioned, yeah, you are right, Max. I mean, it was a great accident. Maybe again, if the McGill equipment was keeping working, honestly, maybe I couldn't get to this level that I am now.
It's really unbelievable, and one of those happy, you know, like you guys are working hard. You've been at this 8 years already, 9 years, I guess, and I'm sure it'll be another number of years as you start to get more and more success and grow bigger and bigger. But it's one of those things where you thank your team, you thank all the hard work that everybody did, but and with a bit of luck. I mean, that piece of luck right there is just unbelievable, and it's really, I think we're all going to be grateful that it happened. And so when you brought this to your advisor and he said, you know, let's protect this, I mean, what was it about that the invention that felt, I mean, it felt very novel, and your advisor has a bunch of experience with this. And so he kind of said, this is we have something here. Is that kind of the vibe that there was at the time?
Yes, basically, yeah. So, I mean, again, I mean, you could find some papers or some published report or some patents on, again, reducing the cement consumption. But making concrete without cement, 100% with other binders, you couldn't find that much of technologies. And imagine that in our process, again, since the technology involved activation of a slag with carbon dioxide, that was something new, basically. We felt that, me and my supervisor felt that, that's something that we have not heard about it. It seems very novel, obvious, and it's patentable, basically. So I guess, again, as you mentioned, that my supervisor had, at this time, he had 25, 30 years of experience in concrete and concrete technology. So definitely he knew that that's something new, that's something that has the chance of being patented, basically. So, and then we didn't stop there, basically. So, because again, as I mentioned earlier, so we presented the case to McGill, and McGill, in order to invest on that idea and on that technology, they had to do their due diligence, and they did it, basically. So they asked the McGill's library. I mean, there are some few people that are working for specifically these type of issues, basically. So let's say, because honestly, every day or every week, few technologies are presented to McGill University, and those McGill universities, they have to somehow figure out if, first of all, this technology is feasible, and second, if that's a new technology, or maybe it's not a new technology, maybe someone else in another university, in another industry, in another country, someone else has been already done it. So, there's no point for McGill to invest basically on that technology. So for that reason, few people are doing some due diligence, and they are looking at different patents, different papers, and different reports. And those guys report to McGill to say that, okay, these reported technology seems novel. There is nothing close to this one, or no, yeah, this technology has been already patented and published, so there's nothing new in it. So these guys basically are submitting the report to McGill, and McGill University, based on those reports, make a decision on if they want to proceed or if they do not proceed with that innovation. So this exactly happened in our case as well, and McGill University did some sort of patent searching. They looked at some prior arts to see if there are any novelty in this, in our case, and they concluded that yes, that's new stuff, and that's a new idea, and for that reason, they agreed to pay for the application.
And they paid for a provisional patent application at that time?
Exactly. I mean, since it's a bit risky for, I mean, I'm talking on behalf of McGill University now, but honestly, since, again, lots of professors and students submit lots of ideas to them, and it's going to be very risky for them if they want to, first of all, invest in all of them, and second, if they want to go to the nation phase and then apply for each individual jurisdictions. So the strategy, I guess that's a strategy for most of the universities and research institutes, that they start with a provisional application. They protect it for 1 year, 12 months. And the idea is that during that 12 months, researchers, students, and professors get more information, get more data, work on the economics, to evaluate the economics of that idea, to validate the data, or perhaps they produce a prototype out of the technology. So basically that 12 months, it gives us and give all the researchers some time basically to get more data and validate the result. And exactly this is what happened in our case. So McGill submitted the provisional patent application, and basically had 12 months to make the technology better, maybe modify it a bit, adjust it a bit, and make a bigger samples, make a bigger products, and all of those things.
And this was the tech transfer office that was engaged in all of this?
That's true. I mean, that's true. I mean, different universities have different names for that office. So at McGill University, they call it the Office of Sponsored Research, but basically the same performance. Basically, this is what they do. Basically, so they are the Office of Sponsored Research. So they are trying to. It's a tech transfer. I mean, working with the IPs, innovation, and all of those things. Yes, same office.
And did you find them to be helpful? I mean, were there difficulties? Maybe you could talk whatever you can share about the licensing agreement and that process, the negotiation, all of that whole experience.
I would say that they were very useful, and still they are useful, to be honest. Because again, honestly, when, at least in my case, when you are a PhD student, honestly, the last thing you are thinking of, at least when you start, is filing a patent application. Perhaps that's none of the task that you are assigned to, and this is not a thing that you want to do, basically, because you have to pass courses, you have to pass exams, you have to prepare the proposal, you have to defend the proposal, you have to write the thesis, you have to do the experiments, and all of those things. So I mean, usually in most cases, the majority of graduate students, they do not do that business of I'm talking about the patent business and IP business. So it was perhaps same for me. And for that reason, I didn't have that much of information on how the patent application works, how the patent protection means, and all of those things, basically. So for that reason, this office, I mean, McGill University, I mean, they were very helpful. They help us a lot. And imagine that, as I mentioned, that how CarbiCrete started with me and my business partner, basically. And that business partner, Chris, was introduced by McGill University. So for that reason, I would say that they have been very helpful since beginning.
And so on that topic, when they introduced you to Chris, I mean, what was how was he presented to you? And it sounds like you two hit it off quite quickly and developed a kind of co-founder bond. I mean, talk to us a bit about how the beginning of that all went down, if you can.
Yeah, sure. I mean, he was a successful entrepreneur, basically. So he had experience in growing the companies, and then he was a great business person, and he had experience in business development and all of those things. In contrast, in my case, my main focus at the time, at least, was developing the technology. So, again, at the time, when you are doing your PhD, basically, you are some sort of a scientist. And again, the last thing you are thinking of or you are working on is the business development or marketing or financial and all of those things. You are just trying to make your technology work. So let's say you are trying to have some progress on your thesis and on your experiments and on your reports, basically. So I had very good experience in concrete, in our technology that I was working on and the technology that I have developed. But perhaps I was not very strong in marketing, finances, and all of those things. So those skills were missing at the time, basically. So it was a very, as I mentioned, we discussed in the past few minutes, that the technology looks very good, looked very promising, it had a great potential, but that's not enough, basically. If you want to start a company or a startup, that's important for sure. The technology is very important. There is no question of that, but that's not enough with itself. So you need to have a strong team. And Chris basically had the other knowledge and other skills that I missed at the time, basically. So he was a great communicating person. He was a great business person, and he had lots of experience in business development and all of those things. So that's why the bond basically started. So technically I was doing very well, I believe. And at the same time, Chris was very good in the business part of the equation. So a good collaboration, a good combination. That's why we are here now, basically, after 6 years.
And you guys applied for and did the Dobson Cup. Was Chris involved in that, or that was before that? The Dobson Cup being the McGill's business plan competition.
Exactly. No, as I mentioned, we started the company in 2016, but we started meeting each other from 2015. So it was in that period that we applied for that the Dawson Cup program, basically. So he was involved on that program as well.
And was that a rewarding program for you guys, or it was just?
Yeah, absolutely. So I mean, we ranked second. We won the second runner-up as a runner-up. So we got some cash prize from McGill and from that program. And it was honestly, it was very good, basically. It directed us, and somehow it forced us to prepare some sort of presentation. You imagine that we are talking about the first few weeks of starting the company, or thinking of starting a company, basically. So it was at a very, very early stage. And this type of program like Dawson Cup basically help us to prepare stuff, help us to think more, help us to be more organized, basically. And then, you know, you have to present something on the market value proposition and all of those things. So it help us to shape those slides and those presentation and those messaging.
And was there other? Can I ask what you did with the cash prize?
Yeah, well, to be honest, I don't remember that much, but we had to buy some stuff, some equipment. I believe we used part of it for the equipments, because it was 2000. Yeah, so I guess we used it for buying equipment.
Because at that point you were no longer working out of McGill's laboratory. The company was formed, and so any future R&D, larger sample sizes, things like that needed to happen on your own dime.
Not really. So after I graduated from McGill in 2014, I kept working as a postdoc, basically, with the same university, McGill University. So I had a chance to use the lab. I had a chance to use the McGill's equipments and facilities, basically, for several months after I graduated as a postdoc, basically. So I was able to basically do some experiments, make bigger samples, and all of those things.
And was any of that baked into the agreement with McGill?
I'm not going to give more details and talk about more details on that one, but definitely CarbiCrete and McGill has some sort of, I mean, we have some sort of agreements basically in place that we discussed about we have already discussed about the IPs and all of those things, basically. So we have a very good relationship with McGill. That's what I can say.
Well, and you said they continue to be supportive and helpful. I mean, is there anything worth mentioning that they're actively doing that?
Oh yeah, well, I mean, yeah, for sure. I mean, honestly, just recently, for instance, because let's say they are introducing and linking us to other researchers, they are linking us to other professors that are doing something that can be useful for us, for CarbiCrete. So basically they are making those links, they are making those contacts and all of those things. So that's why I'm saying that these are helpful for us, these are useful for us, and still is happening, basically.
And is there any other non-dilutive funding that you really prioritized at an early stage? I know Canada has unique programs. Yeah, go ahead.
Yeah, so Dawson Cup was the one that we participated. They are, I mean, not at the earliest age, but there are other governmental program like IRAP, Industrial Research Assistant Program, basically. So basically, this is non-dilutive. Basically, the government of Canada gives some sort of grants for doing research and to optimize the process and basically, help for the product development. This is non-dilutive and that's very useful. There are other accelerator programs in Canada. We didn't use them that much, but again, it depends because in our case, I believe we did not need those type of accelerator programs because Chris was there. Basically, he was a knowledgeable person. He was experienced, and I believe if we participated in those type of accelerator programs, we didn't get that much. That's my personal belief, at least. So we didn't join. But honestly, let's say if you are a researcher, if you are a new graduate, and if you are not experienced on business development, marketing, how to sell, and all of those things, and if you want to get some sort of experience and knowledge and some sort of information, those type of accelerators are the best place to start with. So you apply, you get accepted, you go there, and then you are trained by skilled person, by some person that have experience, and basically you develop some sort of a skill and you develop some sort of information which is useful. So I guess that's a very common route that researchers or the guys who have some technologies that are taking that route, starting from the accelerator program, and they built up on top of that basically. So they start with one accelerator, maybe sometimes they get some cash, 5K, 10K, 20K, 50K, they get trained, they use that cash maybe to hire someone or to, I don't know, buy some equipment, something like that, or do some testing somewhere else. And after that accelerator, again, perhaps they apply for another accelerator program, maybe more advanced accelerator program. Again, they may get some more cash, more trainings, and basically they keep going. That's a very reasonable way to start a startup company.
And something you said a little bit a little while back was you felt that the technology at a certain point was ready to be presented to industry. How early in the process did you start engaging with industry and showing the technology? And maybe you can speak about that. It might be that it's more Chris's domain or whatever, but I'm just curious.
Yeah, it started basically, I mean, it happened basically when we started CarbiCrete. It did not happen during my PhD program, but once we formed the company, and definitely the first thing, I mean, honestly, as a startup, when you are starting a company, definitely you are going to do two things basically: approaching investors and presenting your technology to the industry basically. This is exactly what we have done basically after formation of CarbiCrete. So we had good results, and then we said, okay, that's the time to just go and knock the doors and talk to the industry, talk to the experts, and talk to the people to, first of all, to see the feedback, taste the water basically, to see what they are talking about. Maybe maybe at the time, let's say we didn't know something which was important. Let's say internally we think that, oh, everything is perfect, everything is nice, but when you present it to someone, some expert, someone who are in that industry for 30 years, then maybe they are saying something else basically. So we wanted to see if that's the case or not. Fortunately, everything was okay, everything was good, lots of good feedbacks, lots of positive comments basically we have received from the industry. So basically, yeah, it was after we formed the company that we approached the industry.
And did you always want to be an entrepreneur or in business? Did you have designs on becoming a professor at some point?
Yeah, my niche, honestly, well, if I want to talk about myself, when I started at McGill, my goal and my ultimate goal was to become a professor somewhere. And that was the only reason and the main reason that I started the PhD basically. So, because before I started the PhD, I had 2 master degrees, one in structural, one in material, basically civil material. So, I mean, I have had enough, I guess, degree or knowledge to start working in industry. But I said that no, I just want to be a professor. I want to get involved in the academic field. So for that reason, I started my PhD program. But I didn't think that I'm going to become an entrepreneur. I didn't think that I'm going to start a company. No, none of those things basically. I just wanted to finish my degree, publish some papers, conference paper, journal papers, present some result in the conferences, and basically become a professor in a university. That was my goal. That was my plan basically. But again, in the middle of the program, it has changed basically. So we noticed that again, some innovative stuff is happening there, some innovation is there, some new ideas are there, and then basically the plan has changed.
I'd say it certainly has. I mean, it was just basically the momentum of everything was more interesting than becoming a professor. Like you quickly lost that interest and were swept up in the momentum that is CarbiCrete.
Yeah, exactly. I mean, yes. I mean, honestly, again, because I saw the momentum, I saw the potential. I saw a huge, I mean, and imagine, I believe the impact that CarbiCrete is going to have on the environment, on the planet, on the world, perhaps is going to much bigger than if I just became a professor, basically. I believe that's going to, I mean, my decision to start a company is going to have, I guess, a better and more impact and influence on the world, basically, compared if I just started to be a professor, basically. So for that reason, I believe that was a good decision. I believe that was a right decision that I made. And as you mentioned, that basically, Max, the momentum was there as well. And imagine that that's the timing also is very helpful. So if you look at any media, TV, news, any media, basically social media, almost every day, maybe I'm not exaggerating, but almost every day you see a news on global warming, on climate change, on CO2 footprint, and all of those things. So it shows the potential, it shows the demand, it shows that it's something is needed now, basically, to some technologies, some companies are basically needed to solve this problem and this challenge that everyone is talking about, again, almost every day. But if you go back to, I don't know, 40 years ago, 30 years ago, that was not the case. Maybe 30, 40 years ago, no one talked about global warming, or at least in not that, I mean, not the same context as we are talking now. So the timing is also very helpful, basically, and it's helped a lot, basically. So again, I mean, you look at the governments. They are having a plan for carbon reduction till 2030, till 2050, till 2040. So all governments try to impose some regulations and some laws and some targets, basically, for the carbon reduction. And again, our company helps governments and different, either local governments or federal governments or other countries. Basically, our company helps those governments to meet that goal, basically, reduce the carbon footprint.
Yeah, it's crucial, and you know, the world is grateful to all the CarbiCretes of the world and what you're doing. If you had to give yourself some advice, can be anything, something you do differently, speaking to a failure, what would you tell yourself back in the early days, maybe?
I would say, honestly, maybe it's too cliche, but definitely you need to work hard. And maybe I could have been working even harder. Maybe that's a cliche, but I would say that that's not enough, basically. I would say still you need some sort of luck in your life, and you need a combination of both. If you are working hard, but still if you are not lucky enough, perhaps, you don't get to the place that you would like to get. At the same time, the opposite also happens. If you are lucky and you are not working at all, then also you are not going to be successful either. So I guess you need both factors, which is working hard, and also you need to be lucky as well in order to be successful and in order to get to some points. If I want to talk about what I have done differently, if I want to go back, I would say I would try to be more relaxed. I would try to put less pressure and less stress on myself. Perhaps this is what I would have done if I want to go back.
And any advice to young scientists, grad students, entrepreneurs beyond working hard and trying to get lucky? Anything else that stands out that you'd want to tell them?
Really, I mean, maybe one general advice. So I'm not in a position to give advice, but one general recommendation is that for the researchers, the young researchers, the young graduates, it's very important to work with a professor that is respected in the industry and has ideas and has knowledge, basically. It's very important. Even in my belief, is even more important than the university itself. So let's say if you are a student and you want to start a graduate program, it's good to spend some time and doing some research on the professor that you are going to work with. Because in my case, honestly, my professor helped me a lot, and then definitely without him and without his support, I couldn't get to this position that I am now, basically. He was a knowledgeable person. He helped me a lot. So I would say that, again, for the young researchers, they want to start, they have to think about and they have to search more on who they are going to work with. And perhaps that decision is going to change their life. I mean, I'm talking about the research life and academic life and professional life. That decision is going to change their life in that respect, basically. So if they are able to find the right supervisor and if they are able to get accepted in, that's going to be a good and very huge good start, basically.
Well, that's great advice, Mehrdad. I think this is a good place to stop. Where can people find you?
My LinkedIn, Mehrdad Mahoutian. They can find me on LinkedIn, and if they have any question or any comments, they can shoot me a message, and I will be happy to help anyone.
Excellent. To all who are listening, visit bountiful.work to join our platform and get early access. Mehrdad, thank you so much for joining.
Thank you, Max. Nice talking with you.
You too. Thank you. Thanks for listening. But now we need your help. We're building a community of scientists, students, entrepreneurs, industry leaders, and investors to commercialize meaningful technology and research. Join us at bountiful.work today to find opportunities and realize your power to save the world.